Memorizing the quadratic formula is a rite of passage for most high school students. The reason it's so important is that it's a powerful tool to solve complex algebra equations. In some cases, it's the only way to find the solutions for quadratic equations. But remember, quadratic formula should be your last resort, what you try when nothing else works. Here's my factoring hierarchy. First, look for greatest common factors, or GCFs. Divide them out. Then, if a is equal to 1, just do the normal a equals 1 factoring that you learned in school. If that doesn't work, you might need to do difference of two squares or slide and divide, and only if all of those fail should we use the quadratic formula. So for an equation like this, you should divide everything by the GCF of 3, then factor normally once the a term is equal to 1. Using quadratic formula on this question would be a waste of your time. But there will absolutely be times when you have no choice. You'll need to use quadratic formula. First, make sure that your equation is in standard form. Ax squared plus bx plus c equals 0. When you find your values of a, b, and c, make sure that you bring any subtraction signs along as negatives. So in this case, a equals 4, b equals 1, and c equals negative 6. Then plug those values into the correct places in the quadratic formula. I highly recommend using parentheses to show the substitution. In this case, negative 1 plus or minus the square root of 1 squared minus 4 times negative 6 all over 2 times 4. Start simplifying. I like to think of it as 3 groups, and the first 2 are very easy to simplify. Here we'd just have negative 1, and on the bottom we'd simplify to 8. And then under the radical is the more complicated group, which I usually do in 2 steps. First, 1 squared is 1, then negative 4 times negative 6 is positive 96. Then add the 2 terms to get 97. There's nothing we can simplify from here. We can't reduce any fractions, and 97 is a prime number, so we can't reduce the radical. Your teacher might want you to use your calculator to find the decimal solutions. But just remember that there are typically 2 solutions. That's why there's a plus or minus sign in the formula. We can rewrite what we have as the 2 values. So x equals negative 1 plus radical 97 all over 8, and x equals negative 1 minus radical 97 all over 8. There are 2 big twists that make quadratic formula more difficult. First, even quadratic formula sometimes fails. Not every quadratic equation has real solutions. If the number under the radical ends up being negative, then we'll have a really big problem because you can't take the square root of a negative number. This is where we'd have imaginary solutions. But I want to save that topic for another video. The bigger twist for now is that there are a few arithmetic mistakes that are very common if you're not careful. Let's do another example to see where those mistakes might appear. X squared minus 10x plus 14 equals 0. The first problem might arise when we try plugging the numbers in. Our b value is negative, and the first b that we plug into the formula also has a negative in front of it. People forget about this double negative all the time, which is why I always use parentheses to show my substitution. If I lose this negative, I will be doing a lot of work to get a wrong answer. So our plugged-in quadratic formula should look like this. Negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 14 all over 2 times 1. When we simplify the 3 groups, we get positive 10 plus or minus the square root of 100 minus 56 all over 2. This gets us to 10 plus or minus radical 44 all over 2. Now we have to be careful with how we deal with the division in the fraction. It's very tempting to divide the 10 by 2 or both the 10 and the 44 by 2, but we can't do either of those, at least not yet. First, we need to simplify the radical. I have a separate video on the details of that process. The quick version is that 44 is really 2 times 11. We can pull a 2 out of the radical as a coefficient and leave the 11 behind since it doesn't have another 11 to pair with. Now we can divide both parts of the numerator by the 2 in the denominator, but we still don't touch the radical itself. 10 divided by 2 is 5, and 2 divided by 2 is 1. This entire thing simplifies to 5 plus or minus radical 11. If we were allowed to use a calculator to get the decimal values of the two solutions, we could have done that earlier in the process so that we wouldn't need to simplify the radical and worry about the fraction. But your teacher will often ask for the solutions without a calculator, so you'll need to know how to simplify radicals and know when we can do the division in the fraction. This isn't easy. There are a lot of steps and places where things can go wrong. Use parentheses. Go slow. Don't try to do multiple steps at once. Eventually, the process will feel robotic, even if it still feels a little bit tedious. Remember to like this video if it helped, comment if you have a question, and subscribe to this channel so that you never miss a new video. Thanks for watching.